Okay, we are taking a break from our usual schedule of tutorials because another Road to Las Vegas round happened today. This is Battle 8. This was a really tough one, so we essentially had a pipe maze here with some pipes connected and some not. We had this table here to indicate what pipes can go to and from, so the 2 column, basically the numbers represent up, down, left, right in order. So if there's a 1, it means it can go to that position, so this pipe can go to up and down and come from an up and down pipe. Very tricky to get your head around. The quickest and easiest way to do this case was actually to do most of the questions manually, because it asks things like, are 2 pipes connected? So here you could just see, you know, from left to right, would water kind of flow from the pipe? So this one would be a yes. So in reality, I did this one quite manually. The last question asked, you know, a starting location, AL24, how many of the down pipes are there? So I basically came here and did AL24 to get to the cell and then just counted across here. So 1, 2, 3, 4 down pipes in that example. 4. So that was kind of how I did the hardest question. To do it programmatically with formulas is much harder, but that's what I'm going to do in this video just for instructional purposes. So first of all, let's do some setup. Let's call this MP for map. So MP, let's then do Control Shift F3 and label those. Let's actually start with some bonuses. How many pipes are in the pipe maze, excluding sources and outlets? So I'll do the sum of count if the map says only these pipes, and that will give us that. And then for all the pipes in levels 1 and 2, excluding the examples, how many times can a pipe connect to the right direction? So first of all, let's gather the data from questions 1 and 2. So it's a VStack question 1 and question 2. And let's just put that all in a 2 col. So essentially we get everything in one column that will spill there. And then I just want to see if they're connected to the right. So here I'm going to just do it visually. So that will connect to the right, that will connect to the right, and that will connect to the right. And then let's do X look up those pipes in pipe and give me what I put here. If it's not there, give me a 0. So I want the sum of those. Okay, let's just copy those values. Next bonuses need some questions done, so let's get into it. First of all, we want the binary symbol for all of these and then concatenate them together. So let's X look up all of these in pipe and give me if this equals connects from. Let's just lock that. Then give me from, otherwise give me to. So that will give us all of the details, and then let's concatenate that. So concatenate that and split it down, and that will be our answer for question 1. Quite an involved question 1, to be fair. Okay, question 2 is asking how many pipes can connect to this direction. So again, we know this is kind of up, down, left, right. So what we're really asking is, if we look at where these can connect from, how many have a digit 1 on the end? So let's show you what I mean here. I'm just going to pull these out to align with the others and put that back down here, and let's get rid of our concat. So we still want to be doing our X lookup from this connects to and from, and essentially we want anything with a 1 on the end. So I can see immediately only these 2 have a 1 on the end, so the answer is that 2 pipes can connect to that direction. So I am going to actually say mid of that, and then I want to search for 1 in this, so that would give me position 4, give me 1 digit. And what you see is we now get the 4th digit here, and when we come down we'll get the 3rd digit from each of these pipes. So I just want to sum those numbers up. I actually need to times them by 1 because when I use mid they turn to text. So let's sum those. Again, I find that quite tricky for a question 2, unless you've had a lot of practice at these things. Now it gets a little more tricky. So with these pipes in the exact order they're shown, will they connect left to right? So we want to check if the first pipe has a connection to the right and if the second pipe has a connection from the right. So let's just do X look up this in pipe, give me 2, and let's pull it to the next pipe and change that to from. So we know that the order goes up, down, left, right, so we want one going to the right and from the right, so we just need the last digit off each of these. So I can actually say right. I could use the mid 4-1 as well, but let's not do that. I'm just going to actually change this back to from. Then I want to know if both of these are 1, so I can say and that. And these are not numbers yet, so let's convert them to numbers. Again, using text formulas on numbers can get a bit tricky, so let's drag that down, and I'll say if this, give me yes, otherwise give me no. And that's question 3 done. Okay, question 4, we want to know if these pipes connect horizontally, vertically, or both. They have to be in order, but they can be moved around. So it no longer needs to go left to right. It does the second pipe connect to the first in any way. So we can see in this first question, the second pipe will connect underneath the first, so it's a vertical orientation. So let's do this one with a table quickly. So let's do an X lookup on the first pipe to see where it flows to. And I want to split these digits out. So I have a lambda that does that called split text. I'm going to times it by 1 so they're all digits. And we want the same thing with the next pipe, but we want from direction. So if any of these two numbers are the same, they connect, and then we need to know whether it's vertical or horizontal. So we know it's up, down, left, right, so that's vertical, vertical, horizontal, horizontal. And then I want to say if and this, give me this. Otherwise, give me a blank. Then, if there is a connection, it will come up with a letter. So let's just concatenate that to see all of the connections we can do. Then we want to say if the length of that equals 2, then give me D, because in this situation, D is going to represent being able to go both vertically and horizontally. Otherwise, if the length of that equals 1, just give me the letter that's there. Otherwise, give me N, which means no connections. So that should give us the answer for all those questions. Okay, question 5, a little trickier again. We want to know if pipe 2 connects to pipe 1, pipe 3 connects to pipe 2, and so on and so on. If any pipes don't connect, we want to concatenate the numbers. So here, pipe 2 does not connect to pipe 1, pipe 4 does not connect to pipe 3, and so on and so on. So we just want to pull out the numbers here where the pipes don't connect. Again, they can be moved around as you like, but can't be rotated. So we're going to kind of use this idea that we had up here. We're going to spill both the pipes, and if this is a 1 in any row, it means there is a valid connection. Here we got this V, so we just want to know if the row is the same anywhere. So let's just build that out. Let's say equals let pipe 1 be X lookup this in pipe and give me where it goes to. And we are going to do our whole split text thing. So let's split it down and times it by 1. And then pipe 2 is going to be the same thing but from. So let's just copy that whole thing out and do a pipe 2. This time we're going to go from in our X lookup table, and our pipe is going to be the second pipe. Now I basically want to stack these next to each other, so let's just show you what that looks like. Stack pipe 1, pipe 2. So I want to by row and this to see if both are above 1 and this. So let's say by row we have our array, and we want to say and this should give us the connection, so up, down, left, right. So if we then come across here, we'll see that we get into pipe 3 and 2, and there is a connection there. So we just want to say or on this whole thing. So I'm going to say or that, and then we can drag that across as far as we need to, only up to here. And let's just drag all of that down here. And then I basically just want to say concatenate filter this where this, and that's it. Let's just lock those numbers up there. It's not that, isn't it? So not that. It's the false ones I want. There we go. Okay, level 6 is basically the same idea, but everything is concatenated in a string here. Let's just do it in a data table. Example 6. In here, give me this. So I'm going to say split text of this, and we can see all our pipes. And then we want to know where the pipe's going to go to. So let's say go. Now we want to find where we go to from the first pipe. So we can see here we're going to go down. We're going to use a similar idea to up here. So let's just copy that formula down here and move across our pipe 1 and pipe 2. And let's remove the or. So we can see that between these two pipes, our connection is, so up, down, left, right, it's the down connection. So we're gonna go down from the first pipe. So let's go up, down, left, right. And then I am gonna filter this list where this is true or false. So I can see I get D. Now I'm actually gonna concatenate that because sometimes there might be multiple places we can go to. So here we have up, right. So where are we actually going to go? Well, we came from a down direction, so that means we can't go back up. So we can only go right from this pipe. So we need to remove the up. So how do we do that? Well, we want to remove the opposite of whatever this is. So let's just build that out. D, U, R, L. So let's get the opposite of what we had before. So I'll just show you it out here. So on X lookup this in this, give me this. So that's the opposite. So I basically want to remove that from that string. So the easiest way I've found to do that is to just say substitute this. The old text is that and the new text is blank. That would leave us with our R there. So let's just put that into one formula quickly. So I'm going to say substitute that for this and replace it with a blank, and then we have our go-to location. So let's just drag that all the way up and then back down, and you'll notice we actually have an error here at pipe 4. Well, that is because there is nowhere we can now go from. So we want to go to the right from this pipe, so we go into here, and now because we've replaced the right, the opposite of right in fact, which is the left, because that node's been used, we cannot go left, which means there's now not a connection between these pipes. So it's a bit confusing, but all we want us to do is X match. So let's do if error actually around that. So let's say if error, if error X, and then we'll see we get an X there. So let's just say X match that X in this list. And we get 4, which matches the example. Let's now put this into a data table. There we go. So that should hopefully be our answers, and it is. Okay, level 7. Again, I did this one quite manually, but let's do it with a formula. So example 7, I'm going to do it in a data table over here. X lookup that in here. Give me this. So what I'm going to do is I'm just going to build a start in map and then go. So let's just zoom in a little bit here. So I'm going to start in this cell, and in map I have a lambda for that. So address to contents of this in our map. That's what it is. And then where we're going to go. So let's get our arrows for a second, and I only want those. And let's just label them. So down, up. Actually, we want them in the order of the pipes because that will make it easier later. So let's do that. Let's do up, down, left, right. So down, up, right, left. That was slow. Let's just label our start locations in binary. So we want that's up, that's down. What's left? That and right. Okay, so here our start location is going to be X lookup this in here and give us the arrow. So that's where we're going from the start. So now we can use our move on map lambda. So move on map from this cell with this arrow. We go to Q5. Let's draw what's in the map. So now is the hard bit, but we've kind of already done the work in question 6, I think. So we basically want to know where we can go to. So it's going to be very similar. So let's do X lookup this pipe in pipe and where we can go to. So this is the places we can go to. Let's just split it down again. So that's where we can go. So then let's filter these directions for that. So we can go up and down from that pipe. Let's concatenate it again. And we basically want to substitute out where we came from. So we already have that here. So where the down arrow, we came from down, so we actually need the opposite again. Right, left. So let's substitute that with XLOOKUP the arrow in here and give us the opposite direction. Place that with 0, so we know we're going to go down, and then we can just get our final arrow actually from that. So now let's XLOOKUP down in here, give us our arrow. That might have been a convoluted way to do it, but I don't know. Anyway, now, oh, we need to lock some things. F4, there we go. Yeah, now we should be good. So this should give us a whole path until we get to an ending node here. So all we want to do now is say COUNTIF here and this pipe, and let's put our question numbers in, and we should be good to go. Do we need to refresh? Okay, that doesn't work. I think I haven't put my question numbers in a data table properly. I copied the wrong ones. I do that quite a lot, actually. So let's copy those in to here. And there we go, most of the case solved. Just some bonuses, actually some hard bonuses left, I think. Excluding the example, how many potential connections are there in level 4? So let's do D, H, V, and N. They were all our possible options. D was worth 2, 1, 1, 0. So what we want to do is do the sum of XLOOKUP question 4 answers here, in here, and return the numbers. Now, how many pipes in Pipemare connect to at least one other pipe? So we want to pull out all the pipes here that have a connection. So these two are connected, this one is not connected. So let's build that out. Let's say flatten our Pipemare. Then we want to find out what's up, down, left, right of our given cells here, because we can't connect diagonally. So let's say 2 row arrows, and let's just delete the 4 here. Okay, let's give us some space. Then we want to find out what is in the positions if we do these moves. So let's say move on map C3 with this arrow. That's going to give us our move. Let's just do some locking here. So this needs to be locked that way, and this needs to be locked that way. Then we want to do address to contents of that on our map, so that gives us the pipe. Next, we're going to do something similar to what we did earlier. So if we're coming down, it means we're coming from an up pipe, which is the first digit. This is the second digit, this is the third, this is the fourth. So let's now XLOOKUP that in pipe and give me 2. I think we actually want from here because we're going the other way. So if this, let's just think about this. If this is the pipe in C3 and we want to move down, we want to be able to go from a down position. So up, down, so actually that's going to be 2, 1, 4, 3. So then I want to do mid that. Here's our number. Let's lock it to the row. We want 1 digit. So there we go. Let's do if error blank or something. I'm sure that will be fine. If error, let's actually do 0. So now, so let's just center this up to make it a bit cleaner. Now we have a 1 or a 0 for all the pipes that are in those cells and whether they can connect from something across. So we need to know if the pipe that's in our original cell has a 1 in the same positions here. So let's do XLOOKUP this in pipe and give me 2. Then we want to split this out the same way as we have here. So let's do mid that, and we want to go here. Let's lock that, and we want 1 digit each time. So that gives us all the digits. And where these two are 1s, we will line up and have a connection. So let's first times it all by 1. Again, let's just center up here so we're clean. So we have 2 arrays here, and we want to compare cell by cell in those arrays if they're both 1. So this is a great use of map. So we can have map. Here's our first array. Here's our second array. Lambda A, B. What do we want to do? We want to say and A equals 1 and B equals 1. Then we get a bunch of trues or falses, and then we just want an OR, because if any of those are true, then there is a connection. So we should see some trues in here, hopefully. I can see that we haven't, we're still using text here, so I think I just actually need to times this by 1. And now we get some trues, and let's just wrap that in a minus minus, and then our sum there should be all the connections, so 1504. 1504, okay, good. Then, if you trace the path of the pipe sequences in level 7, they spell something. What is the full message? So, we basically want, in this level 7, all of these paths. So let's quickly grab that here. Let's do equals 2 row of cell addresses, and then we can do a data table on that whole thing. Here we go. Now let's basically X match whether any of these addresses are in our paths, because that will give us our letters. So let's say is number X match C3 on 2 col all this stuff. We want the example as well, don't we? So let's use that, comma 3 to get rid of the errors. Then we have a false. Let's do a minus minus to give it a number again. And then basically where this is a 1, it's in our path, so we want to spill the map. We also haven't locked our grid here, so that's crucial. Let's just do that. Many mistakes today. Okay, we have some cells now. So then on the map, let's have a look. There's 44, I think 44, how many cells? 48, so there's 48 columns. So I'm going to say wrap rows, this 48. And what we'll have is we'll have a 1 where all of our letters are, basically. So let's just actually make this smaller, like this, so it's a square grid. And basically I want to say if that's a 1, give me the map. So I'm just going to say if that, give me the map. Otherwise give me a blank. And then we have our letters, so summer, come, lord, graduate. I've never heard of that phrase before. There's a double M. Yeah, and that's it. 1, 2, 50 points. So apparently this means best in class or something like that. Not a phrase I've ever heard, because I was never best in class, but there we go. When I originally did this question, I didn't know that the letters would all already be in order on the map. So I did basically a reduce across this grid, did the same method like for the first row, then I H-stacked it with the second row and the third row, and what I had is I had a map here with just 1 letter in, then a map here with another letter in, and then I could scroll across and like see all the letters after sort of zooming out. That's a really cool bonus. I love bonuses like this where you're moving like things around and it makes letters. You can kind of see it now that you know in the grid like where the connections are. You can sort of see letters here if you squint your eyes. Yeah, very cool. Good case. Hopefully this video wasn't too long. It was a hard case, so don't worry if you didn't understand all of that, but yes, I hope you enjoyed.